Hello everyone, a couple of questions here from a few of my students that are doing 3D vectors at the moment. These questions, they look like a lot of what the hell is going on, but when you understand what the information is telling you, these kind of fall out. They're quite simple. I'm going to leave this up the whole time. I'm going to do question number 7 over here and then I'll rub it out. Then I'll come back to question number 10, question number 11. So just skip forward if you want one of these other ones. Let me read question 7. It says, the point with the position vector, AI plus 7j plus 5k, lies on the line with vector equation of 2i plus bj minus k plus lambda lots of minus 3i plus j plus 2k. Determine the values of the constants a and b. Right, now I'm going to give you a tip here. This is my best tip. This language, this notation is absolutely fine, but if you kind of can't see what's going on, use notation like this and you might see it a little easier. Here we go. Let's go. I'm going to do this. I'm going to go A, 7, 5. That's that point, isn't it? Now, if that point lies on this line, then I should be able to do this. Equals 2, 1, minus 1. Oh, sorry, B. Plus lambda lots of minus 3, 1, 2. No, I've missed something in there. Where's my A gone? Oh no, that's okay, my A's here. Okay, so there's my A and my B. I might just put them in different colours. Now, that must be true. That must be true. If this point lies on this line, then there must be some lambda value that when I calculate this, I get that. I'll say that again. If this lies on this line, then there must be some lambda value that when I put it in there, this will equal that. Now, if that's the case, and my colour coding's helping heaps here, I cannot solve that line there. You're thinking, what do you mean that line? Well, isn't this the I component? A equals 2 plus minus 3 lambda. I can't solve that because I've got an A in there. I can't do that. Here, same, I can't solve it because I've got B. I don't know what, I can't solve that. But here, can't I solve that because the only unknown I have is lambda. So pull out the k's. 5 equals minus 1 plus 2 lambda. I can solve that because there's only one unknown in there. So move the 1 over, that becomes 6 equals 2 lambda, therefore lambda equals 3. Now if I know lambda equals 3, then that means when I put 3 in right here, that times that, 3 times that, plus that, must equal that. Well, another way of putting that is to say, why don't you take lambda of 3, put it in there, and now, let's solve this line. Wouldn't I have A equals 2 plus 3 times minus 3? Minus 9, A's got to be minus 7. Let's do the B line. We're here. So 7 equals B plus lambda times 1. Well, that's just going to be one lot of that. Move the 3 over. B is going to be equal to 4. So my answers here is that A is going to be equal to minus 7. And B is going to be equal to 4. Now, if you want to check, what you do is you put your 3 in here, you put your 4 in there. Work this out, and it should come through to these numbers and minus 7. So once you see it in this format, and you see I've got enough information here, yeah, the rest is just arithmetic. It really is once you've seen it. Hopefully that works for you. Let's get on to the next one. Here we go. Right, next one says, let me have a quick read, number 10, prove that the line of this guy is perpendicular to the plane of this guy. Now, remember with this plane idea, this here, this is a plane formula, okay? Now let's just do a recap on that. That is in the format of r dot n equals a dot n. Now if that means nothing to you, go and watch the video on this, okay? Because that's how we define things in this style of format, okay? In this style of vector equation, this is what we do, and this just becomes C. The reason is that we will know one of the points, the other point we don't know. So we will end up with R, let me rewrite this in a nicer format, 3, 2, minus 1 equals C. Now, they didn't tell us what C was. I don't care. It doesn't matter in this question. Because, look at this, we want to prove that the line is perpendicular to the plane. The line is perpendicular to the plane. Now, key understandings here. When we're looking at a line, this part here is giving us the direction of that line. This is my start point, and this is the direction of the line. So there we go. Let's draw a little graph. Here is this, right? Don't worry about the numbers, it's just a sketch. That is that first part, right? Let me color code it better here. Let me color code it, right. So that's the first part, and then this, again, don't worry about the direction, is, oh, I might change that a little bit, is that, okay? Follow the color code. Now, that there is, if you like, the gradient of that line. Now, it's not necessarily flat because it's three-dimensional. Maybe it's out here somewhere, okay? But that is the gradient of that, okay? Or gradient of sorts, okay? Right. Now, let's dive into this guy. Do you remember that with this formula, this particular vector here, that is perpendicular to the plane, okay? Or perpendicular to the line if it was just 2. So this is perpendicular to the plane. So if I've got this here, then that is perpendicular to it. That is the normal, right? And if I want to prove that that is perpendicular to that, well, this one is perpendicular to the plane. So therefore, I want to prove that the normal is a scale factor of the direction of the line. Go again. This here is defining that. That is defining that. And I want to know, is that line perpendicular to the plane? Well, for it to be perpendicular to the plane, it must be parallel to the normal. So the normal and the direction must be parallel. Now, you're hopefully already ahead here. I look at this and I say, well, that guy there, 3, 2, minus 1, times some factor, I might go equals some factor, times, times, right? Now, if that's true, if I can find some k value that works, that means that the direction of the normal is parallel to the direction of the line. Think about that. The direction of the normal is parallel to the direction of the line. Well, that means the plane and the line are perpendicular. Okay? And because in this case, what are we going to have? K is going to equal minus 2 in each case. Then the answer is yes. The normal and the direction of the line are parallel. So therefore the plane and the line are perpendicular. Oh, there's a lot in that. If you can see that, that's something you always got to just look for. Look for scale factors between these things to know what's happening. If there's not a scale factor, then they're not perpendicular. Okay? If there's not a scale factor, then they're not perpendicular. Hopefully that one, there's a lot of thinking there. A lot of thinking there. Okay? How do you answer that question? You show there's a scale factor, therefore k equals minus 2. Therefore, the plane and the line are perpendicular to each other. It's a little bit of wordiness just to explain, that's all. All right, question number 11. Show that the lines L1 and L2 intersect and find the position vector of this point of intersection. Now, because of the work we did here, we're kind of already on this, right? I would do this. This will take me a little while to write out, but here we go. Follow with me. I would go 10, 5 minus 2 plus lambda lots of 4, 1 minus 2 equals 0, 8 minus 6 plus mu lots of minus 1 minus 3, 5. Right, so we've got all that happening. Hopefully I've copied the numbers correctly. Now again, if I just look across this top line, can you see how I've got two variables? If I look across the middle line, I've got the same two variables. So I'm not going to calculate this one for you, but this is what I would do. I would take the top line and I would take that line. Write the equations like this. 10 plus 4 lambda equals, well this is easy, 0, so it's just going to be minus mu. There's one formula. Two variables, one formula. Second line, 5 plus lambda equals 8 minus 3 mu. Now there's two equations, two unknowns. I should be able to solve that. Now, I did say I wasn't going to calculate that. Let's do it. Okay, I'm going to multiply this line here by 4. Now, you could do it on your calculator. I don't use those things. They scare me. Not really, not really. So, here we go. Let's do this. So, 10, I'm going to minus away here. 10 minus 20 is going to get me minus 10. 4 minus 4 is going to get me 0 lambda. Right, so I don't need to worry about that. Equals, well the 8's by itself, so it's going to be 0 in here, really. 0 minus 32. And then minus 1, minus another, what do we got there? That's going to be minus 12. Minus 1 plus 12 is going to be plus 11 mu. Okay? Now, put this guy over to here, that's going to become positive. So that's going to be 22, I think. That's working out pretty neat, isn't it? So therefore, mu is going to be equal to 2. I could then take that, put it back into, well, either one of these. This is probably the easier one. So this would be minus 2 here. Bring it over, it would become, bring the 10 over, would become minus 12 over here. So lambda would have to be minus 3. Okay, knowing that, then all I've got to do is say, okay, well that's fine, take those, put it into either one of these, I don't care which one, doesn't matter which one, and I'll find the point. So I'd probably, it doesn't really matter, they're both about the same. Take these numbers, put them back in there, get your point of intersection, okay? Hopefully that one works for you. Thanks guys, see you later.